Trevor, you got some awesome projects. Let's hear about them.
Alright, so the power's off, so I can't show you how it actually runs, but this is a camera controller, motion controller.
Yep.
It's got two axes, up and down and left and right. And so I designed and fabricated this whole mount for my camera. And what I do with it is I take time lapses that can have, you know, panning motion, so the frame is moving as well as the subject. And all these parts are water jet out of aluminum. There are some stock parts like the gears and the pulleys and such, but everything else was custom. And I control it with this controller down here. There's an Arduino microcontroller and two stepper motor drivers. And that controls the motion, but then I have this other guy which controls the camera itself. So it tells the camera to take pictures every X number of seconds, which you can set with these buttons. And so once it's all running, the camera's taking pictures on its own every 10 seconds or so, and the motors are running, and then it ends up being a really cool video with sped up motion. And so this thing is something that I put together just for the Maker Faire, actually, because I figured it'd be really boring for people to see my camera moving really slowly. So these are just some knobs that you can turn, and if the power was turned on, then you'd see each one of these would turn one of the motors. So, you know, this would be left, right, this would be up, down, and you can control the position of the camera.
Does it open up?
Yeah, so it's pretty simple on the inside. It's just some potentiometers, and it sends the position of those knobs back to the brains of the whole operation, the microcontroller.
That's right. And then that controls the steppers.
That's right.
Which then controls the.
All right. So here's one of the steppers, and then you can see.
There's another one down below.
One of the axes there.
Okay.
Yeah.
And tell me about your Geneva gear.
Yeah. So this was actually a school project. The other one's for personal stuff. It's for my thesis, and it's a really beautiful, fully mechanical device that I fabricated and designed. I mean, I didn't design the idea of the Geneva drive, but this particular model I did. And it takes a continuous rotary input and converts it into a sort of a stepwise output, so an incremental output. It's just a really beautiful mechanism that isn't really used much anymore, and many people, especially kids, wouldn't know what this is. So I thought it'd be cool to make kind of a museum-style display. People can interact with it and see how it works.
That's great.
Yeah.
And what do we got over here?
This is a little custom solar panel. I actually got these panels for free. Put them together into an array, which can generate maybe like 2 watts maximum. That energy from the sun goes into this battery, so I can charge devices at night when there's no sun, and it can be any USB device that I charge. So this is a voltage conversion circuit. Has a regulated 5-volt output, so I can charge iPod, cell phone, or whatever. So I charge my cell phone off the grid in my dorm room.
That's great.
And then this guy is sort of a homemade camera.
It looks like my field camera.
That's right. So it's got a lens at the front, and it's got this homemade bellows, so the back can move forward and back to focus.
Yep.
And with the kicker is that I use a scanner, a flatbed scanner, to take images, and that's what sits right here. You can get really wacky effects if you move while taking a picture. Your face gets all smeared out, and you can get double noses and all sorts of weird stuff. So anyway, that's
neat. Where can people find out about your projects, Trevor?
So I've got a website. The URL is trevorshp.com. HP stands for homepage. And I also do a lot of work at the MIT Edgerton Center. So it's a great resource for really anyone to come in and build cool stuff.
That's great.
Yeah.
Well, thank you so much. I'm glad you came out to the Cambridge Mini Maker Faire.
Yeah, it's awesome. Thanks.